Welcome everyone for today's session, today's webinar conducted by Zuku Consulting. And today's topic would be what changed in Mechanical Spice version 2.0, which is recently released. And before getting into the webinar, I would like to give you a brief introduction about what is Zuku Consulting. As I can see from the participants also, most of you already know. And if someone is new, then I would like to give you a brief. So actually, Zuku Consulting was established back in the year of 2014 by Mr. Sunil Kumar, who is having an extensive experience in process improvement with European, German, China, and Indian automotive car manufacturers and their suppliers worldwide. Also, Zuku Consulting in itself is having a worldwide experience and does have experts from different countries who are providing various services based on their portfolios. And we also work with the partners who are expert in their own fields and do provide integrated and complete solution in process improvement. Our business areas, as I have tried to list them over here, we do provide services for automotive spice, for improvement, for consulting, for assessments, trainings, functional safety, ISO 26262, automotive spice for cybersecurity or ISO 21434, agile spice. For this, there are new, recently Intex has released their trainings, Intex certified agile spice trainings, also conducting assessments based on agile spice, data management spice, mechanical spice. Yes, for this also we do provide services, hardware spice for this as well. And recently it also got integrated in version 4.0 of automotive spice. Okay, and mechanical spice, yes, this will be our topic for discussion today. It's new Palm version 2.0, which is out. And this Palm can actually be downloaded from the Intex website itself. If you have already gone through the Intex website, you would have found all the Intex spice, all the spices written over there, and whatever is available, the latest Palm which are released, they are freely downloadable from that website. Along with that, we also provide integrated approach, or let's say an integrated services. Here, what I'm trying to say or what I'm trying to highlight is that our approach or Zuku's approach is not to make different set of processes based on the standards. But what we actually try to do is we combine all the processes or all the domains which you are looking for, and we try to come up with one set of processes for your organization which will satisfy the need of all the standards. Let's say you want to go for automotive spice, functional safety, and cybersecurity. It's not like you have to create different set of processes for all different for A spice, for 26262 or 21434. You can combine everything together and just create one set of process that is for your organization. So this was our business areas. For services, we provide three main services: assessments. For assessments, it can be your gap analysis, your pre-assessment, formal assessments, or your internal assessments also, to help you achieve the desired capability level for whichever domain you are talking about. Then we also provide services for consulting, where we try to guide you from the very beginning and try to improve your processes or try to define your processes based on the domain you want to go for and to achieve the level which you are looking for. Other than assessments and consultings, we also are training provider, and we do provide Intex certified trainings along with our Zuku certified trainings. So when I say Intex certified trainings, what I'm referring is your provisional assessor, your competent assessor trainings, and all the plug-in trainings, let's say your cybersecurity, agile spice, VDA guideline training, your data management, or any other spice which is coming into the market. We do get it registered and we become the training provider for that area. And then we get started. So this was about Zuku, and then some more information about our credentials. We are member of INTEX, and we are also INTEX representative for India, advisor to China and Korean Spice Network. We are accredited training provider feed from VDA QMC and also from ECQA. So actually your Agile Spice and Data Management Spice are under ECQA. Okay, you need to be a registered training provider with ECQA to conduct your INTEX certified trainings for them. For some of the certification which we have within the Zuku Consulting, we have INTEX certified instructors at competent level for different domains. We have INTEX certified instructors at provisional level for ASPICE for cybersecurity. We also have INTEX and ARCS certified principal assessors, INTEX certified competent provisional assessors, and then also the engineers or professionals from functional safety, cybersecurity, and many experts and senior consultants. So this was about our credentials, and here this is our footprint. When I say our, it's the Zuku's footprint. And along with that, we are located in 2 locations, India and USA. So we have 2 different offices. One is in Noida, India, another is in California, US. That's all about Zuku Consulting. And now about myself. Hello everyone, my name is Meghna Chahar, and I have been working with Zuku Consulting since 2017. I think it's almost more than 7 years. I am working as an assistant director and senior consultant. I'm also an INTEX certified principal assessor and instructor at provisional level for automotive spice for cybersecurity. And I do have experience in mechanical spice, hardware spice, your 26262, 21434, TIE6, have been providing trainings for all these standards, also conducting Gate for Spice as a moderator or as a presenter. I do conduct INTEX certified PA trainings as well. Also, I did get a chance to conduct INTEX or your automotive spice assessment for maturity level 5. So that's just a brief introduction about myself. And now moving ahead for today's webinar. Some of the points which we need to know before I get started. By now, you would have already noticed that your mics are muted and camera is turned off. Yes, that's intentionally it is done. So your mics will be muted, cameras will be off as it is a webinar. And we do use a Q&A facility of Teams. So all of you would be able to find one Q&A section in the Teams header maybe. And please use that facility or the feature for writing down all your queries throughout the webinar. And we will be collecting all the questions from the Q&A. All the questions will be either answered during the presentation by one of my team member itself, or by at the end of the presentation. If we don't get time, then I'm going to list down all the questions, and later on after the webinar, I'll try to answer them and send across the answers for you. And this webinar will be recorded, and all the slides and the recording will be available on our website. I have given the link over here. And also, if you navigate to zuku.co.in, you should be able to find this on the very first page itself as a webinar. You can go there, download the slides. You can also go to YouTube, our channel, to download this recording. So that's all about before getting into the main topic. Today, my agenda would be, I'll be talking about 4 main things. First is, what is mechanical in system? Then just high level differences between a previous version. Here I have to consider version 1.8 and version 2.0 of Mechanical Spice. Changes in processes. I have tried to take some examples. I have not considered all the processes, but just tried to couple of processes to show you the difference, actually, what was there and what is there now. And then some information related to traceability throughout all mechanical processes. So very first, what is mechanical in system? Here, actually, again, as I said, before I get into the difference between the mechanical spice two versions, I would like to discuss more related to what is a structure of a vehicle, let's say. Or maybe I should say a picture of how it is now in the world of automotive spice 4.0. And I think that would be the best way to get started with spice. And I also believe that all of you would already know that SPICE is not a model that is giving us any clear specification of how something should look or how something should be structured, but it is a model that only describes what is expected at the end at the end, but in no way it is telling us how you actually implement in the companies. So it is defined at what is needed, not how you are going to do it. Okay. But we kind of have a product structure. So here you can see with this diagram, and here what I'm trying to explain also is a structure, your product structure. We have a vehicle, we have a mechatronic system, which can be further divided into mechanical, your drivers, motors, ECUs, and so on. Okay. So we simply broke down from top to bottom here, from top to bottom into individual areas. Okay, and that is exactly what Automotive Spice is trying to do. Here, whenever you see there are more than one domain. So here you see we have software, hardware, housing, combined everything is ECU. And for Automotive Spice, ECU is nothing but a system. Okay, so we can say whenever there is more than one domain come together, it is a system in terms of a spice. Now let's take another example. We have hardware, software, or mechanics or electronic interfaces. Now these interfaces have to be handled somewhere, and that is the task of a system. And for that, we do have our system development processes, which we are having from previous version of Automotive Spice already. So system requirement, architecture, system testing, verifications, that already is present. And also software processes. So here for system, yes, we have. For software, correct. Again, for software, the complete V-cycle is there. We have software requirement, architecture, detailed design, construction, unit verification, integration, and your qualification. Very well structured software processes. And with version 4.0 of Automotive Spice, they have introduced hardware as well as machine learning processes. So before 4.0 integration, or let's say before Hardware Spice got integrated into Automotive Spice version 4.0, it was already present. There was a different PAM for Hardware Spice consisting of all 4 hardware processes. But those 4 processes, after some modifications, some more enhancements, got incorporated within Automotive Spice 4.0. And yes, machine learning. But here, what is missing? 4.0 is having these things, but the missing part is our mechanical. Okay, and yes, this would be my topic for today, discussing the mechanical spice version 2.0. What is defined there? Will it be incorporated within automotive spice or not? Maybe or maybe not. We don't know right now. Okay, so yes, mechanical is missing. Now, within the framework of mechanics, we are still trying to see at least a logical division where we are dealing with the two things. We have mechanical systems and we have components also. So we want to see a logical division where these systems, mechanical systems, when I say mechanical system, I'm referring to pure mechanical system in which several mechanical components would be interacting with each other. Okay, so now this interaction is a lot different from the interaction, or when we say at the system, we have different domains coming together. Yes, system level, different domains are coming together. But in mechanical, we have mechanical components in itself interacting with each other. Okay, so what I'm trying to say here is that this image is showing the hybrid of multiple domains. But do you really think in reality it is so easy to divide everything? It's not. We cannot, force hardware, mechanical, software from each other. In reality, it is more a recommendation approach for a product structure. Yes, you can very well define a product structure, and depending on what all is in your scope, you can clearly pick or from all the processes, whatever process is applicable for you. You just pick those processes, you try to implement in your project and get started. So with 4.0, we get system, software, hardware, and machine learning. Addition, we have mechanical spice, which is giving us mechanical processes. If your scope is mechanical, yes, you can very well pick processes from this spice and incorporate them in your project. So this was about what is your mechanical in a system. After this, let's look into some high-level differences between version 1.8 and version 2.0. Here, what I've tried to do is, actually version 1.8 was created on base of Automotive Spice version 3.1. So this was our ASpice PALM 3.1, and I'm sure all of you would already be knowing this diagram. We have 3 different life cycle, different process groups, 8 process groups having system, software, supporting, and all other processes from organizational life cycle. Now, by considering this structure, Mechanical Spice version 1.8 was defined. So this was 1.8, where we had mechanical system engineering process group. We had mechanical component engineering process group. So what they had done, they simply removed the entire system and software and replaced it with mechanical system and mechanical component engineering process groups, consisting of all 9 processes. So initially we had different processes. We had system requirements, system architecture, mechanical system integration, mechanical system qualification test, 4 processes for system engineering process group. At component level, we had 5 processes with the component requirement, component design, sample production, test against mechanical components, and test against mechanical component requirements. So you can clearly see they simply replace the system and software with mechanical system and mechanical component. Now, before we see version 2.0 of Mechanical Spice, here I have shown you the Automotive Spice version 4.0, which was released last year. So here, what they had done was all the processes which were not being asked by majority of the companies, OEMs, and they were not very much used, they tried to remove those processes. So here you can see acquisition process group. Only ACQ4 is considered. All rest, everything was removed. Same way, supplier process group. Only product release was left. Similar supporting process group. And additionally, yes, we still have 3 life cycles, but we have more process groups. So 3 new process groups were added in Automotive Spice PALM 4.0. For hardware, as I was saying, we have hardware processes 4. We have 4 machine learning engineering processes. Validation, yes, somewhat we can try to map it with SIS1. Now, based on Automotive Spice V4.0, Mechanical Spice. So this diagram, again, I have taken from the PALM, which is already present on Intex. What they are trying to show is, similarly, how we had hardware and machine learning, mechanical can come up as a plugin to our Automotive Spice, next to our machine learning or hardware or anything, and they have come up with these 5 processes. Okay, so now we don't have 2 different process groups. They reduced it to only 1 process group, calling it as mechanical engineering process group, consisting of 5 processes, starting from requirement, design, production, verification, and verification against your requirement. Very much similar with our software processes, if you see. And here, the interesting part is, PALM Mechanical Engineering as plugin to ASpice. So yes, it may be considered as a plugin for Automotive Spice. But when? I don't know. Now I'll try to make the comparison to these topic or to the topics of your software processes. Okay, so here I have shown you mechanical engineering processes, all 5 processes. I'll try to map them with your software processes because, well, I do think that the software development, according to Automotive Spice, it has been there from a long time, and there is a very nice, clear way that we know, which starts from requirement, architecture, design, construction at the bottom, and then on the right side, all the verification or test processes. In the terms of mechanics, it does look little different, and that's why what we try it will like this to compare them a little bit so that the assessors, actually above all of them, need to get a better understanding how these processes are divided. Okay, so for the first MEE1, our mechanical requirement analysis, it is almost similar from the principle point of view, from the structure point of view. You will find it is very much like software requirement analysis process. We need to write the software requirements. Same here, we need to write the mechanical requirements. We need to structure them, prioritize them, do the analysis, feasibility analysis we need to do. We need to do traceability, everything in line with SWE1. On the right-hand side, MEE5, verification against mechanical requirements, is very much similar with a software verification. And here, before I go ahead, another point is, if I go back to previous version, on the right side of the V were the testing processes. We were having test against a mechanical component, test against mechanical component requirement, or against your mechanical system qualification test. But as the new version is based on Automotive Spice version 4.0, they have tried to stick to the same terminologies or same explanation or the structure. And that's why here you're seeing all verifications. Okay. So yes, MEE5 is similar with, or you can say almost like SWE6. When we go for MEE2, here we have two things. We have mechanical architecture and design. So here we are considering two things, mechanical system architecture, okay, and the component design. So what we used to do in software, we had one software architecture, then we used to go for SWE3 process. In SWE3 process, we used to have one detailed design process dedicated, okay, and then unit construction. Now what they have done, they have taken out the detailed design part, let's say, or the fine drawings or the diagrams. They have considered that in MEE2 itself. Yes, in detail, I will be discussing this process later. So for now, you can try to think in a way that your mechanical architecture and design process, again, from the structure point of view, from base practices point of view, is similar to software architecture design process. And which is on the right hand side, we can map this MEE4, your integration and verification against mechanical architecture and design, is similar with our software component and verification and integration verification. Okay. Now the interesting part comes as soon as we talk about SWE3 or we go for the lowest point, because here we have now found that a kind of interim solution with a single process. Okay. And what we have tried to explain a little more clarity, that actually means if we take this process SWE3 that describes the model for Automotive Spice, then we have both topics. So as I was saying, we have two topics. We have detailed design and we have a unit construction. Detailed design, we can try to interpret in the term that it is a fine design of your component, okay, and component somewhere, and the unit construction. The unit construction part is your actual implementation according to the design, which we have recently created. That was there in our SWE3. So we have both logical development activities of the design and also let's say the code as our physical result. Okay, so both of them work together. And here in mechanical, this thing has been divided. Okay, so now we have two parts. We have MEE3 and MEE2. So the detailed design part here, you can try to map it with the component design here. And the end result, or when we am saying the your end product, yes, here we have the sample production. We can try to map that over here. So the idea of detailed design that I was stating at the architecture level was that the sub level or the component down to the smallest level, we try to refine or describe, okay, with a detailed design when principle represent, and now that is a part of our MEE2. That means your actual design process and separate from that is actually the physical production. So this is a separation. One process dedicated for the design, another process dedicated for your physical production. And here one more point we need to consider is MEE3. So actually in principle, it is not a completely new process as I was saying. Here also we are having end product production. And here also we used to develop our source code. Okay, so it's not something out of the box has come up a new process altogether. No, it is there, which we can try to map with SWE3. Okay, so just the thing is now we have two different things. Okay, it is not completely new. The result have basically flowed into two processes for us. Okay, then that of course means that we also need to get a verification that the verification result of MEE3 is from your sample production is in line with our design over here. So whatever design we are developing over here, this production needs to be in line with this design, and we need to verify this product against this design and architecture. So here you see it's kind of a triangle for us. Okay, so that's what actually with this, I just wanted to point here is that we are kind of coming up with a triangle down here, and we can imagine this triangle often we do see it in ASPICE also in some trainings because we have now three elements. All these three elements needs to fit together in some way or the other. So we have a design for our mechanical component. Let's say, for example, your drawing that is giving us the clear picture or telling us how a component should be realized in the end. And we have the component itself that has been realized and we have the verification against it. So which means we have three areas that now fit together. So we have two that we want to compare with each other, and this is exactly the idea. Okay, so the idea is that we have here is we get the component from MEE2, we take out the component, based on it, we come up with the production, and then that is verified in MEE4. Another important point is MEE3, it does not describe your series production. Okay, but in it only talks about the support for sample production. So it is about the pattern, how, what really we are going to do from the development area. It is only about support. So how can we work after it from the development side? That is the focus. Okay, so what we have is we have requirement in line with this. We have architecture and design similar to SWE2 or 3. Then we have our sample production. This is not for series production, but support for it, giving what all specifications should be there, what type of testing should be there and all. And then we have verifications which are in line with the software process. Now here, before I go to the next slide, I would like to point out that this is a model. Okay, And model is not saying that your organizations or when you are actually implementing it, your processes should look exactly same. Okay, that's not possible. And when I go to the traceability section also, I'll try to give more inputs there. It can be different from your working. The expectation is you need to have requirement, you should have architecture, component designs, and then support for production and your verification. Okay, so here, yes, I just wanted to compare the mechanical spice processes with SWE processes just to give you the idea how these processes are defined. Now, going ahead, now here the comparison between version 1.8 and 2.0. As we have seen in the previous diagram where I was showing all the processes, we have three categories, three life cycles. Okay. And here I'm not trying to list down the difference because of version Automotive Spice version 4.0, but I'll only focus on the difference from mechanical process point of view. So here previously we had two different process groups. We had system, we had component. Now both of them are combined together into one process group that is called mechanical engineering process group. So we don't have system engineering or component engineering as a different. Now, because of this change, initially we had 9 processes. Now, these 9 processes have been reduced to 5 processes. And due to these reduction in the process, 69 base practices have been reduced to 30 base practices. So yes, here we see these two processes no longer there, combined together and formed one mechanical engineering process group in version 2.0. Now, what does this mean? First of all, why did they reduce 9 processes? They reduced 9 processes and came to 5 processes. Why not 6? Why not 4? Or why altogether it was needed? Actually, as I was saying, mechanical spice can come up as a plugin. Okay, so they want to keep consistency throughout all other plugins, all other spice models. And that was the reason they wanted to have only one process group. And by having these 5 processes within the process group, it is more than sufficient. As we have already seen, we have requirements, we have design, we have production, we have testing. Everything is there. We don't need to further divide it. And when we go for further dividing, it gets very complicated when you're in actual development. So where to include which process? It's not so straightforward. So they try to make it more generic. And that's why this reduction. Now, because of this reduction, does it mean that we have to do the less work? Actually, no. From the working point of view, no, you don't have to do less work, but you do get more flexibility. Now you are, when we say you get the flexibility, we just have one process, MEE1, for mechanical requirement specification. Whether it is your mechanical system requirement specification or mechanical component requirement specification, you just have one process to execute now. Okay, so they just tried to make it more simpler, more in line with other process groups like software, hardware, and all. So our work does not reduce, but yes, it is more streamlined now. That's all for high-level difference between the difference between version 1.10 and 2.0. Next is changes in the process. Here I tried to take these 3 processes. Okay. I'll try to go into discuss all the processes from process overview point of view, then going into their base practices. I'll not go in the technicality. I'll just stick to what was there in the previous version and why they have been combined together. Have they removed some things, or it is just the combining both the things together and keeping in one place? So very first, merging of the process. We had 2 different processes for requirement, as I was saying. So here you can try to focus on the colors. Whatever you see in this color, orange color, is from our mechanical system process group. Next is our mechanical component process group. So Mechanical system requirement analysis, the main purpose of this process was to write down or to drive the mechanical system requirements from upper system requirements. Here you need to pay attention. Okay, so we have to come up with mechanical system requirement from our upper system requirements. When we talk about the component requirement analysis, here the purpose was come up with the requirements for mechanical components. Now, what they have done, this is the new process, mechanical requirement analysis. The purpose of this process is to transform all the mechanical related parts of the defined upper system requirement. Yes, it was their upper system requirement, but now this upper system requirement can be your mechanical system requirement itself. So let's say we have mechanical system. Under that, we have one more mechanical system, or we have mechanical components. You are trying to drive the component requirement or the sub-mechanical system requirement from your upper mechanical system requirements and the upper mechanical system architecture. Okay, yes, here also it was something similar, but they had not explicitly mentioned it. And if we look into your software process, software requirement specific analysis process, there also we say you need to drive the software requirements from system requirement process and your system architecture design. Same way, we need to drive or transform the mechanical related part requirements from upper system, upper architecture into mechanical requirement, which are going to guide us for mechanical system and mechanical component designs. Okay, now here I'll try, again, I have used the same colors just so that it's clear. It's coming from the which process. So this is from the first color is from the system, mechanical system requirement process, mechanical component requirement process. And then we had base practice for specifying the requirements. Same thing is being copied here, and they have combined these two base practices to come up with one specified mechanical requirements. So what interestingly they did, they just removed your system or component. They said specify mechanical requirements. And if we go to the explanation here, we can say that use your system upper system or upper system architecture requirements and try to document all functional and non-functional mechanical system requirements and component requirements. So nothing is removed. Okay, they just combined it. Instead of having two processes, two different DPs, have only one. By using this process, you do both the works. Next base practice for structuring. This also, they have simply combined. Okay, we need to structure and prioritize mechanical system requirements and as well as mechanical component requirements. Now, the example for structuring criteria can be your grouping by functionality or by expressing your product variants. And let's talk about prioritization. Again, prioritization can be done based on depending on your project, your stakeholder needs, or based on your releases, what is in your scope, your samples. You can prioritize. But again, we need to do this activity for system as well as for component. Going ahead, analyze. Here also just combined. Okay. Analyze the specified mechanical system and component requirements, very much similar what we already had. Okay, we need to do the analysis for technical feasibility, for correctness, for verifiable, and all other project parameters for resources. Okay, so that you can actually help your project manager. Next is analyzing the impact on operating environment. Here also, nothing removed. They simply combined and said you need to analyze the impact of the mechanical requirements will have on the element in the operating environment. So no change, just combine. Here is a change. To keep your mechanical SPICE 2.0 consistent with automotive SPICE 4.0, they removed this base practice. Okay. Verification criteria initially was a dedicated base practice in automotive SPICE PALM 3.1. And in the previous version of Mechanical Spice, yes, we did have a dedicated base practice, but this has been removed. Instead of a base practice, they have added one note in BP1. Okay, note 3, that your requirement should be written in such a way or by using your state-of-art characteristics that the requirement is verifiable. We don't need a dedicated verification criteria at a place, but you write your requirement in such a way that just by reading the requirement, it gets clear how we are going to verify it. Okay. So yes, there is no separate BP for verification criteria, and this change is very much in line with 4.0 change. Next, when I talk about traceability and consistency, this also what they did is, so previously, again, because of 4.0 changes, consistency and traceability based practices have been combined together. And now when they're combining two processes, so 4 BPs have been combined and linked with only one base practice, that is ensure consistency and establish bidirectional traceability. But interesting, nothing removed. As I was saying, they just combined. We need to maintain traceability and consistency between system requirement, upper system requirement, mechanical system requirement with upper architecture design, from component requirement, mechanical system requirements, same with mechanical system architecture. You see these two coming from these two, and same way the below two are for component. And here I just tried to explain why this change was done in ASPICE also. Why they decided to come up with to combine two base practices together for traceability and consistency. So if we look back before version 3.1 or 3.0 of Automotive Spice, and we see Palm 2.5, that time also we just had one base practice for traceability and consistency. There were no two different. But what was happening? People were misinterpreting this particular base practice. They were developing the traceability metrics. They were trying to have a traceability, but what was happening was the consistency part was getting missed out because the model was also new. People were new, organizations were new, they didn't know, or they just skipped this part. And because of this problem, in 3.1, they tried to come up with two different base practices, one dedicated for traceability, one for traceability and one for consistency. And now again, they have combined these two and made it one. Okay, just give me 1 minute, sorry. Going ahead, next, communication and agreed mechanical requirements. No change, they have simply combined. We still need to communicate all system requirement and component requirements. That's all for requirement analysis process. Next is our mechanical architecture and design process. Here, what they did is, the main purpose of this process was to establish architecture design and also to identify that which all mechanical system requirements are allocated to this architecture design, and then evaluate your architecture design against your defined criteria. This was the purpose. For component, the main objective was only to evaluate your design for the mechanical components. Now what they have done, they combined these two, and they are saying the purpose, you need to establish mechanical system architecture for this one, mechanical component design for this part. Now you need to comprise of static and dynamic aspects consistent, which should be consistent with your mechanical system requirements and component requirements, and also to evaluate this architecture and design against the defined criteria. So here we can see all these base practices from architecture are combined, okay, for development, for allocation, for defining interfaces, special characteristics, or develop mechanical component. And we just have one BP now. Actually, two BP. One is for static aspect, another is for dynamic aspect. Okay. where they have tried to capture all the information, like you need to have a static structure, you need to define functional, non-functional system requirements, component requirements, including your interfaces. Everything needs to be documented. Next part, dynamic and static behavior, develop mechanical component design. We have one BP, specify dynamic aspects of the mechanical system and mechanical components. Okay. So here we need to include the behavior of mechanical elements and their interaction in different modes. Okay, how they're going to interact. So basically the dynamic behavior for both the things, architecture and design. Here there is no difference. Consider, determine and document design constraints. Same thing is present now also. Another point is evaluate. So evaluation or verify part. Everything is combined together into one BP. BP3, analyze the mechanical system architecture and component design. Now this analysis, how we can analyze, or some method for analyzing can be, or the techniques for analyzing can be your prototype, your simulation. Okay, and the simulation methods can be your FMEA, FEA, CFD. Okay, we need to identify and document the special characteristics. Now, these special characteristics can be identified with the support of simulation, some sizing calculations, technical aspects, maybe with respect to manufacturability, suitability of your pre-existing elements to be reused, and availability of your elements. So all these parts we need to analyze. Everything is done within this one BP. So what we were doing against these four is against one now. Here, same concept, traceability, consistency have been combined. First change, second change, two process, two BPs combined together. So in total, 4:1. Okay. Communicate, here also there is no change, just the combining of these two. We are still need to communicate static system architecture related information, mechanical component design to all the affected parties. Sorry. Next is our mechanical component sample production. So actually, as I was already saying when I was explaining the entire hierarchy of all the processes, that this particular process does not deal about your actual production, but it is about the support. Okay. Supporting, it is about the production mechanic, producing your mechanical components, which basically represents the design. Okay, so we take both your component design, component description, requirement of the components, and of course the design that contains your geometric data. Okay, the diagram which we had created in the previous process in MEE3, that design will be taken into consideration. But that's the really about this process is really about compiling all this information. So for the mechanical components, a sample part is already available to the supplier, and then also corresponding the production specification in order to have your specification for how it has to be produced. Okay. So we are just giving them the specification how to do the production, perhaps which test or let's say which tests are necessary, which procedures are defined, have to be applied, because this information is often required from the development point of view, and we are still at the development side. So production in itself is out of SPICE scope, or it is not in the focus. Okay, so the main point is it is support for the production. Okay. In this process, you will not see major changes from version 1.8 to 2.0. The main difference only is against Automotive SPICE 4.0 changes. So as you would have already, I believe you already know what were the main changes from Automotive SPICE 3.1 to 4.0, the strategy part. Okay, from all the entire right side of the V, the strategy part had been removed, from level 1 and moved to level 2, okay, PA 2.1.1, but all the information related for that process execution were still present at that process. So same way they have tried to modify this process. So this particular process is only coming from one process group. There is no combining of two processes, just one process, reiterating the base practices or the purpose. So here we can see mechanical component product strategy we need to define. Okay, but now they're saying the purpose is to produce your mechanical component sample that reflects properly with your mechanical component design and your mechanical component sample production specification. So the strategy has been removed. And that's the main difference. That's what you will see in all the BPs. So the BP1, if I talk about, it was develop mechanical component production strategy. Simply they have removed and they're saying you need to develop mechanical component. What do they mean by mechanical component? They're saying you need to have a specification for sample production of the mechanical component, and this mechanical component sample production specification shall be consistent with mechanical component design, which we developed in MEE2 process. Okay. Agree on component production strategy. Yes, we still need to get the agreement, but for the specification. So you need to communicate the agreed mechanical component sample production specification. Okay. Now, all affected parties can be your engineering or your sample shop productions. Here, ensure and support production of mechanical components. Just the name change. Now they're saying produce the mechanical component samples. But if you go down and further read this base practice, they're still asking the same thing. You need to ensure and support sample production for your mechanical components according to your component design, your component production strategy, and you record your production data. Okay, this needs to be recorded according to your specification. Going ahead, traceability consistency, same reason, it has been combined. Here also, both the base practices combined into one. Last, providing feedback. So we summarize and produce the production data, summarize the production data from our sample production and communicate it to all affected parties. That's all for the difference between few of the processes. Next, traceability. Here, not a major change. Just one thing I wanted to highlight was this was the traceability defined in version 1.8, where we had upper system, mechanical components, production, and right side testing process. And this is what we have now. So here, each was a different process. But here, what you are seeing, almost similar, but the main difference is this process and this process are same because they have been combined. Same thing here, these two processes are same. This is different, still different. These two again, same. And these two as well, same process. So if we go in detail, yes, you might find some differences like your consistency traceability combined. So we just have one BP. Here we had two different. And somewhere here we were every time saying upper system. And for component, we were directly linking it with mechanical system. Here also you will find the same relations. Okay, only difference is with the process perspective. And with this, I think that's all I wanted to present for mechanical spice differences. So I know the time was little less and I think I'm almost on time or overtime. I'm not very sure. I need to check once. So just wanted to give you a brief what has changed, why it changed, is it in line with Automotive Spice 4.0 or not? And with that, that's all from my side. Here, I've just kept a screenshot from Zuku's website for our all upcoming trainings. If you feel you want to go for any training, you can directly go to our website or you can scan this QR code and get in touch with us. So I think that's all from my side. Thank you, everyone.